In this video, I'm going to show you how to build a simple RAG chatbot end-to-end using LangChain, OpenAI, ChromaDb, and Gradio. Now, to build a really good chatbot is actually quite involved. There's a lot you have to do to optimize how you retrieve the information and how you generate an answer. And you've got to do a lot of thinking about who your users are going to be, what types of questions they're going to have, and what types of answers they want. But before we get into that, let's at least get the tech working end to end. Now, as ChatGPT likes to say, let's dive in. First and foremost, we have to get our data and put it into some kind of vector store. In my case, I decided to use transcripts of YouTube videos from a channel called Nutrition Facts run by Dr. Michael Greger. And I actually have a background in nutrition and dietetics and before becoming a data scientist. So this is an area of interest where I'm a subject matter expert, which is actually very helpful when you're trying to evaluate your chatbot, right? Now you can use any data you like. This is just what I chose to use. The process is still the same. First, we're going to actually I'll clear all the outputs for you just to make it interesting. Let's load in our imports and our settings, and I have the OpenAI API key hanging out here in a .env file, and with this .env import load.env, I can get access to that API key and use it when I need to. So that's a handy way of storing your API keys and other secrets and so on. And then you'll see how all of these different classes are used as we go through the video. Okay. So step one is I'm going to instantiate my embeddings model. I'm using OpenAI embeddings. You can use whatever you like. I'm using the latest and greatest called Text Embedding 3 Large. Now I like to go over here and let's see here. These are your options. You could use large, the small one, or the older one, Text Embedding Ada 002. And if you want to see pricing, so we have OpenAI models pricing. Always good to keep an eye on that. Let's see what this is going to run us. If you do that, openai.com/pricing, you can see it is 13 cents per 1 million tokens. I calculated the number of tokens. It was somewhere around 2.5 million tokens. So, all right, I don't know, 35 cents maybe to vectorize all my data. So I'm fine with the cost. Okay. But if maybe you want to use open source embeddings, that's totally fine too. Now let's read in my transcripts. I collected all these transcripts in a previous step. I'll make a separate video about that. And here you can see I've got a couple of these weird unnamed columns and then some other information about each transcript, including the video ID, title, description, when it was published, and so on. I'm going to actually take the step to remove unwanted columns, because when I feed this in at a later step into my vector store, anything that isn't a transcript is going to be included as metadata. This is all going to become metadata, so I don't want this stuff in there as my metadata. That would just, it's not clean that way. Now we'll get started with our first LangChain class. Called the data frame loader, right? There's this concept of loading in the data, and it's always good. I want to go back to the documentation. Let's see what else is available, right? And there are lots of ways to load data. You can, as you can see here, there are custom data loaders. There are, you can load it from CSV, from a file directory, JSON, Markdown, whatever. In my case, I'm using the Pandas data frame loader. So all I have to do is say, here's my data frame, and this is the column with the text that I want you to vectorize, right? So then I actually do loader.load, and let's just check this out, right? Because we're learning, we want to find out how all this stuff works. What do I have in loader? I can load and split. I can check out, okay, what am I using for page content? Transcript, very good. I can also see, okay, there's the data frame that I'm using. Great, everything looks good. Now, how about these docs? What's docs all about? Whoa, here we go. Now the transcripts, right, that data, the information from the data frame, right, the transcript and all the other columns have now been converted into a special class called a document class. The document class includes this page content. See, it's a list of documents. So let's look at doc 0. Okay, scroll back up here. And let's check out page content. Now this will give us just the transcript, okay? And we can get our hands on the metadata this way, and the metadata is included as a dictionary, right? So if we want to get a specific thing, like maybe we just want the title, we just index in there like we would with any dictionary. See, docs, the first one in the list, dot metadata, and then give me the title from the dictionary. Okay. And you can also, just for fun, just see all the keys you have in your metadata, right? Okay, great. So we have our docs. Now we need to split them because some of them are small and some of them are several thousand tokens. And it's very important when you're vectorizing documents, you're vectorizing data, to have a chunk size that isn't too big so that the meaning just gets diluted because there's so much text, right? Because we're going to take that text and turn it into a vector that's supposed to represent its meaning. But if you have tons and tons of things in that document, then that vector it's not going to be very specific. And if your chunk size is too small, then the semantic meaning will be lost. So this is something that you need to play with, okay? And you can try different ways of splitting the text. But for the purposes of this simple thing we're doing, we're just going to use just standard from LangChain website, this recursive character text splitter. I want a chunk size of 1,000 characters and chunk overlap of 200. Okay, what that means is that, let's say, instead of having your first chunk being from character to 0 to 1,000, then 1,001 to 2,000, instead I'm going to have 0 to 1,000. Then I'm going to have 800 to 1,800 and so on. So I'm always going to have that overlap, right? And that's to try to ensure that each chunk that the semantic meaning doesn't get lost. And again, let's have a look. Let's go over here, text splitters. Have a look at the documentation. Always read the documentation. See what else is available. See what's going on. You can split by token. You can use these experimental text splitters. Do by markdown, right? Because if you have markdown, you want each little section based on your markdown specific characters to be vectorized, right? So yeah, think about that stuff. Anyway, what I'm doing right now, I just kept it super simple. All right, now we're going to split the documents, and now let's see what happened. All right, in our original data frame, we had, let's see, df transcripts.shape. Oops. We have 2,569 rows or transcripts. So when we first turned that data frame into those docs objects, we had 2,569 of them. Once we split them up, we now have 17,808 documents, right? And each one of those, let's have a look at one of them. Each one of these little chunks right here, that's what's going to be vectorized in the vector database, and that is what we're going to search against when we make a query to our RAG chatbot. And you can see, all the metadata is still in there. Okay, that's what. Now this is the big step where we instantiate Chroma, and we say, Chroma, take these documents, which are now stored in this splits variable, use this embedding model, vectorize, and store it for me, and persist it in this directory. If you don't do that, you'll be able to use this vector store in memory, but once you shut down your notebook or your environment or whatever, it's going to be gone. So then you'll have lost that. So I have mine, here's my Chroma database that I created. It's hanging out over there. Right. Now, I've already done this, obviously. I'm not going to redo it right now. But what I am going to do in this step is, and what you should do, is to then read it back from disk just to make sure it's working properly, okay? Let's see, code is right there. And let's test it out. Here's my query. I want to find out about eggs and diabetes. I want to, K is the number of documents, right, that you want it to retrieve. I want it to retrieve 10, why not? And I don't need to see everything. I just want to see what titles, right? So here, look, metadata, title. All right, here, you'll see what it looks like. And I'm doing similarity search with relevance score. So I'm saying, hey, get me my metadata and also get me the title and get me the score. So you can see I'm getting 2 chunks of transcript text from eggs and diabetes, and then one from bacon, eggs, and gestational diabetes, another egg one, and so on. So yeah, that's pretty good. It's not bad, right? So you're gonna run a few tests just to see what's going on. Now, I want to show you that with this vector store, what else you can do, right? You can add documents and text. You can do this marginal relevance search, similarity search. You can do it, just give me back the titles, give it to me with scores. That's what I did. There's a raw score, then they turned it into a relevance score. You can, again, check out the documentation to see what all this means and see what you can do, right? And but when you want to use this vector store in the RAG chain that you're going to create with LangChain, you're going to put this retriever wrapper around it. And so let's see how it works when you turn it into a retriever. Here you have to put the K that you want. Instead of just doing here's my query and K equals K, I put it in here, search quarks equals in this dictionary. And so just, again, it's one of those things where you'd be happy I just showed it, it's here in this notebook. You don't have to go looking for that in the documentation. And then let's see if we do that same query, if we get the same results. And it appears that we do. Great. So we know everything's working fine. In this case, we're not getting the scores, but that's fine. It's just giving us the texts that are ordered by relevance, and that's ultimately going to be passed into the context window with our query to then do our LLM call. Let me do one more thing just to prove to you what's going on. This is what the full results look like. You can see it says list of documents, and how many are there? We expect 10, right? Because we said K equals 10. And here we go, we have 10 of them. So it's just 10 of the most relevant documents, okay? Now this is very, very basic. As I said before, if you want this to work well, you may have to get fancy, like you search for these small chunks, but give the LLM the full parent document so it gets all the information in the context, everything in that transcript in order to answer the question. Maybe you want to vectorize summaries of each document. Maybe you vectorize questions a person might have about the documents. You may want to optimize the chunk size, use different types of retrievers. All stuff we're going to cover later. First, got to get those get the basics to work. That's how I always feel. Get end to end first. Okay. Now we've created a vector store. We're happy. Seems to be working okay. Let's now get into the fun part where we're going to create the RAG chain with LangChain, okay? We're going to see what that means. We get our imports and settings. We're going to instantiate the embeddings model again. And now we're going to instantiate the chat model. Again, I'm using OpenAI GPT-4 because when I build prototypes of stuff, I like to start with the most powerful model and then from there see, well, what can I get away with, or can I fine tune something? Can I use GPT-3? But out of the gate, I like to, go with full power. GPT-4 Turbo, most recent version. Again, let's just check out what else we've got here. It's a good GPT-4. here are the options. Actually, I could have just called it GPT-4 Turbo because it's pointing to this one anyway. But anyway, you get the idea. And let's see what this is going to cost me. Yeah, wow. It's $30 per million tokens input and $60 per million tokens output. Like, you know, that's a good chunk of change, right? So I don't want to do anything at too large a scale with this. I just want to play. And if I use GPT 3.5, then it's much, much cheaper, but the performance is much, much worse. I mean, generally speaking, I gotta say, get what you pay for. Right. So anyway, okay, we've instantiated our models. Now, remember, we're gonna bring that Chroma from where we saved it from disk, create that vector store. I'm going to set k equals 5. I want up to 5. I want 5 results when we do the search. And when I get back those documents, remember that the documents, they're kind of, you know, where was I? Look at this. This is what we're getting back. So we need to format this. We need to, before it goes into our query, right? Because we're going to say, hey, LLM, answer the question based on this context. I need to format that context. And that's what this format docs does. It just says, hey, take each document, the page content, remember just that transcript information, and then separate each one by 2 empty lines. Okay, pretty simple. Okay, let's do that. Now let's just test out the retriever again. I've already shown you that. And then let's see what those formatted, so this is how it would look. This is what would go in. Oh, and look at this, is interesting. I have some French transcripts. I think I forgot to specify English only transcripts. And I was going to go back and fix that. But I thought, hey, that's fine, you know, because the LLM knows French too. So why not? Why not? And I did minor in French, so I should be able to read that. But anyway, I'm not the one reading it. GPT-4 is. Okay. Now, I was kind of thinking it'd be cool to not just have this stuff. I also, what if we also said what the title of the, gave the title of the video, you know, eggs and diabetes, bacon. I wonder if that would give a little bit more context, maybe useful, maybe not. But this is more an excuse for me to show you how you can modify what goes into how the context is formatted, right? Here I reached in and I got title from metadata and then new line and then page content and so on. And so you can get creative depending on your use case, okay? Okay, so I've formatted the context. I'm retrieving the documents that are relevant. I'm formatting them so that it's going to look nice for the LLM when I send it. Now I need a prompt that's going to wrap around all of this stuff. And you can get a pre-written prompt from LangChain, the RAG prompt. You know what? Why don't we start there? Let's see what they've come up with. They're the experts, right? So this is their prompt. It's taking in 2 variables, context and question. The prompt is, you are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say you don't know. Use 3 sentences maximum and keep the answer concise. Now, this is where things really go back to your use case and your users. Do your users want 1 sentence? Do they want 3? Do they want a more in-depth answer? I mean, if I'm asking questions about, I don't know, eggs and diabetes and my health, do I want more than 3? Do I really want to hear? Do I want more, right? Maybe. So it's likely that I'm going to want to change this. Maybe I want it to answer, you know, in the same sort of slightly sarcastic tone that Dr. Gregory uses, or maybe not, I don't know. But those are all fun things we're going to play with later, okay? So for now, let's just use out-of-the-box prompt. I think that's totally fine. Okay. Now, we got a prompt. We've got our retriever. We've got our formats docs function. Let's put it all together using LangChain Expression Language, which is confusing. We're here we are. You can learn more about LCEL. You can just, give me some basic code for RAG. That's really where I started. My way of I learned by reading the documentation. I read the documentation, I work through the examples, and then I find that's one of the best ways to learn. Anyway, all that being said, here's what's going on. It's saying, okay, I with this chain, I'm going to put in my question. That question is going to go into this retriever, and then whatever comes out, those docs that come out are going to go through this format docs process to give me my context variable, right? So here, because my prompt wants context and question. And then my question is a runnable pass through because we're not going to do anything with it. It's just going to pass through, and we're also using it here. And so this context and this question then go to the prompt. Prompt is it formats everything nicely with this sort of wraparound here. You're an assistant, blah blah blah, and all of that goes into the GPT-4 model, whatever model you're using, and then we do this string output parser at the end just to get the answer. Okay, so we can get just the answer, not all the other stuff. So let's give this a try. RAG_chain.invoke query eggs and diabetes. Let's see what we get. Okay. Research indicates that consuming eggs is associated with an increased risk of type 2 diabetes. Studies have shown that even eating a single egg per week can significantly raise the likelihood of diabetes, with higher consumption leading to even greater risks. And so actually I picked this question because I know it's very controversial. It goes against the traditional dietary advice. This is something very specific that Dr. McGregor has researched, and he's pulled out articles on it and so on, and that's his advice to people with type 2 diabetes. So that, again, being a subject matter expert, it's fun, actually. You kind of helps you, it really helps when you're evaluating something. Something like this, and while you're building it. So anyway, okay, yeah, this seems, I'm getting my 3 sentences. Okay, fine. So our next step, now that we've built the chain, is we want to generate the function. I'm going to go over here again to the documentation. I'm going to create a chatbot with Gradio that looks something like this. Okay, and I need to be able to tell this what to do when someone hits submit. Okay. When someone hits submit, I'm going to get message and history. I'm not going to do anything with chat history right now. I'm just going to take the message, put it into my RAG chain, and get back an answer. Okay? And then that answer is going to be displayed in here. All right? So I create this function, and then I use this Gradio Chat Interface again. Just go here, can have a look at some of the documentation and play around with it. But it makes it pretty simple to prototype, right? You don't need to add in any of this stuff. All you need is the function. I just did it because I wanted to get fancy. I put in a title, a description, and I said I don't need the retry button, undo button, or clear button. I just want the submit button, and that'll be fine. Oh, okay, hang on. Forgot to do this. Gotta do this. Okay, now let's launch it. We can launch it right from our Jupyter Notebook. Isn't that cool? Okay, here we go. I have diabetes. Are eggs good for my health? Eggs may not be good for your health if you have diabetes, blah, 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 right? Can you tell me more about the research? This is a trick question. It's a trick question because I have not set up this bot yet to be able to distinguish between questions for which I want it to go to that vector database to get relevant documents and answer based on that context, versus just asking questions based on the chat history, right? So we'll get to that at a later time, right? That gets a little bit trickier. So when I said, can you tell me more about the research? It talks about Dr. Gregor's research overall. It doesn't tell me more about research on eggs and diabetes, okay? Interesting. But anyway, all right. At least we got something to work, right? We've got to start with the basics. But now, I kind of, even though it's basic, I want to just get one step a little fancier, which is I want to not only get the answer, I want to know what videos were referenced, because maybe I can just go back and then watch the videos that are relevant to my question, right? And so to do that, you've got to modify this chain a little bit. And again, very confusing because we're using LangChain, but the question comes in, you get the context from your retriever. The question is a runnable pass-through, so it's passed to the next step. And then we're going to get our answer from this RAG chain from docs, where it's going to take the context, format it, put it into the prompt with the question, put all that into the LLM, and give us our output. All right, so this does, in fact, work. I'm just going to delete this. Let's check it. Don't know why I have result.keys. You can see it's giving me context, question, and answer. Right? I've got context, question, and then answer here. And let's just have a look at the result. Here's all my context. Okay. And then here is my answer. Where'd it go? And here's the answer. Okay. So you can see here, I kind of need a post-processing step, right? Because I'm getting this context, question, and answer, and I can't just, need to format that into some kind of nice string. So I write this function called format result. And here I'm saying, okay, give me all the titles. And remember, I had this set here because sometimes the same video will be referenced more than once, because multiple chunks from the same video can come up in your results. Then I'm getting myself a list of titles, ideally of relevant videos. I would have the actual URLs, but when I got the transcripts, I didn't also get the URLs, but I'm going to go back and do that in a future step. So stay tuned. And then I want the answer. I don't need the question again. I want my response to be the answer, 2 new lines, and then give me the relevant titles formatted nicely. And there you have it. Okay. So now if I want to test this format result function, here's the answer, and then here are the relevant videos. Not bad. Not bad at all. Now again, I want to rework my function that's going to run when someone hits the submit button, so that it uses the new RAG chain I created, and then it takes that result and it puts it through the format results function. Okay, do that. Alrighty. How am I doing this? Okay, well here I'm testing it. And you can see I get the question, I get the new lines, and then I'm just testing this function, make sure it all works. If I do print, then it'll come out nicely. There you go. Okay, so this I think this is gonna work. Now I just pop that into my chat interface and I say, okay, I want you, when I hit submit, I want it to do this. Alrighty. And now let's launch it. All right. I can view it here in the notebook or here on a local host on this URL, or, I did share equals true. So I think it's even going to give me a shareable URL. Does it? Oh goodness, this is a free public URL. So I can, share that with a friend and try it out. Fortunately, it expires in 72 hours because you don't want that to just be up and running forever. Okay, so here, eggs and diabetes again. Moment of truth. Okay, it's thinking about it, and here we go. Here's the answer. Here are the relevant videos. Oh, I just wish there was a link and I could click it and take me to the videos. All right. Let's get that on the product roadmap, pop it in the backlog. I'm going to do that in another video. But now I'm going to show you how to actually run this in a .py file, right? So I have my imports here. I bring in my OpenAI API key using load.env. I've got my embeddings model I'm going to instantiate. I'm going to instantiate my chat model. I'm using GPT-4 Turbo. I have temperature of 0.5. I'm bringing in my vector store. Make sure you get the persist directory correct. For a while, I couldn't figure out why this wasn't working, and it's because I had the wrong path to my my Chroma vector database. So don't make that mistake. And then here I'm going to set my vector store as retriever, k equals 5. Here I am pulling in my prompt. I've got that format docs function here. I've got my chain. I've got this, my format results function, right? It's my format results function. And this is the function to generate the answer, okay? And then here is the actual chat interface over here. And now we are ready to go. Okay, now all you have to do is do Python apprag.py, okay, and oh, I forgot to import runnable parallel, so let's do that right now. Runnable parallel, and it does not like, didn't like something. It should be LangChain community. That's how it wants me to import LangChain community. Okay, let's see if that works. I don't get yelled at in the messages. And now let's try it again. Alrighty, time for the moment of truth. Here we go. Eggs and diabetes. Okay, there you have it. Thanks for listening. See you soon.